Hello and welcome to another HiddenLayer webinar. Thank you for joining us wherever in the world you are. I was going to say like good evening because it is in the UK, but then we've got other people who it's not evening for yet. I don't even know if it's lunchtime for you guys yet. But yeah, welcome. It's really good to have you here. This is kind of like the third in the series of webinars that we've done focusing on agents and the risk that agents impose. We had one with one of our guests, Kaz, way back in the day, talking about governing and how you do governance around AI agents. We had another one where we focused on some attacks with another one of our guests, Ken. And then the reason we're all here today, I'm going to blame it all on you, Kieran, is because Kieran has been looking into some other cool stuff where we focus on skills, and we're going to get into all of that today. I'm Jim Simpson. I work on the Intel team over here at HiddenLayer, but I'm going to get the rest of the panelists to give a quick introduction of themselves. So first off, the reason we're all here today, Kieran Evans, take it away, mate.
Thanks, Jim. Appreciate the blame. So I'm Kieran Evans, based in the UK. Worked at HiddenLayer for 3 years now in the security research team. Prior to that, I started my career in digital forensics and then moved into cybersecurity incident response before coming on board here and researching the fun stuff.
Sounds good. All right, we'll go over to Ken Yeung.
I'm Kenneth Yeung, security researcher at HiddenLayer. I've been on the adversarial machine learning research side for 3 years now at HiddenLayer. I poke around LLMs, been around since GPT. Lots of fun stuff in this space.
I love the fact that that's now like a way to date yourself, right? Like I've been around since so like GPT. All right, okay, cool. And then last but by no means least, Kaz, do you want to take it away?
Yeah. Hi, I'm Kasimir Schulz. I'm actually the director of the security research team that Kieran is on as well. So I get to see his marvelous work every day that I'm so happy that we get to really talk about today in force. My background is more traditional security research. However, of course, now I'm at a AI company. So it's perfect for this webinar of attacking AI agents. So you have prompt injections and all of the other fun little bits that you have with AI, but then trying to see how traditional security vulnerabilities can be exploited through AI as well.
I think that's kind of where like it's that real confluence is kind of what we're going to focus on today, right? Like it's not just the AI, but the implementation and we can get into wording now. We were having a quick chat before like all this started, and I was like, okay, can we talk nomenclature because I don't know the right words to use anymore. So on the last call we had when Ken and Connor were on, I described like the wrapper around an agent as like the orchestration, right? Like the orchestrator that holds everything together, and words have emerged that this is now what we're talking about today. And when we're talking about coding agents like Claude Code or Cursor, they're actually referred to as harnesses. Ken, Kaz, do you want to like elaborate? What words should we be using around this kind of stuff?
Yeah, so I'll let Ken actually go into the harnesses because I think he's going to talk about some of the attacks as well. But since we are in, trying to define some wording here at first, I want to, before we go into harness and what that is, I want to also make sure that we clarify prompt injection versus jailbreak, since that's something that comes up again and again. And today we're really going to be focusing on prompt injections themselves. So especially with, something like a coding agent, if I tell that the coding agent that it's supposed to do anything, help me with anything, and I ask it to delete a file, and the coding agent helps me delete a file, that's not a prompt injection. That's you asking the model to do something and the model complying with it. A prompt injection is when you tell the model not to do something, and then somebody, an attacker, either directly or indirectly, is able to still get the model to do something. And that's different than a jailbreak, because with a jailbreak, what we're trying to do there is we're trying to get the model to tell us some information that it's not supposed to, rather than getting it to perform an action. But with that clarified, Ken, do you want to go into harnesses?
Yeah, sure. So harnesses are kind of what wrap a model and get it to go from language model, which is just a box that predicts the next word, to something that is functional, allows us to do a lot more with it. Right, think like your Codex or your Claude Code, Cursor. All of these are language models that have access to different kinds of tools, different kinds of features, different environments that it can interact with, and really become, much more productive of a tool than if it were just predicting the next token and having you, copy paste with it and interact with it through the world.
Cool, I appreciate it. I try and give credit as well, like to the other people that you don't see who are actually making this work. So we've gone completely off script already, and Ryan is keeping up. Ryan is the technical guy behind all of this, makes us look amazing on here. So thanks for keeping up, Ryan. So yeah, we did have like a rough agenda, but it's kind of, we're going to cover these topics as we go throughout the day. So this isn't like a step-by-step what we're going to cover, but these are the points that the examples we're going to give you kind of make and that they're going to drive home. So we're going to be looking into sort of like key security insights from evaluating coding agents. Like, what have we learned about these coding agents and some of the subtle ways in which an attacker may take control of what that coding agent's able to do from a prompt injection. That's right, Kath? Because it's not, we're doing some, okay, cool. All right. And then we're going to look into hooks, harnesses, orchestration layers, and how those can expand the AI attack surface. Some ideas potentially around how we can make architectural decisions so that we can try and keep the agent doing what it should be doing, rather than doing what indirect prompts might be telling it to do, and some secure by design principles. So we're going to try and wrap all of that as we go along this like journey of like where we started, where we are now, and kind of how things are going. So on that basis of where we started, do you want to give us a run-in, Ken, of as to where we were? I don't know, where like 6 months ago when we were looking into like the initial cursor type things that you were looking at, and how those worked.
It's probably been over a year actually since those cursors.
Is that long?
Yeah, it has. It just about has. But yeah, we were initially looking at cursor when it kind of first breached, I guess, the public eye. And it was a lot of different kinds of attacks that could be done on the auto run mode, right? Because sure, you could have an agent kind of deal with you in VS Code. We've seen that with Copilot, but that's not really that great in terms of productivity when you're trying to get a lot of stuff done all at once, right? You want an agent that can go and do things that you've approved it to do on its own without you having to check in every 5 seconds to approve a different task. And so the auto run mode was interesting, but it had a few pitfalls, and there was a lot of different kinds of bypasses that we're able to do on the actual auto run, I suppose, framework itself. And that allowed us to get things like SSH keys exfiltrated out. We looked at a bunch of different tools and saw that different kinds of markdown were rendered, could use those to extract things as well. Specifically, the mermaids diagram tool was able to render links in SVGs. And we did all this kind of stuff to kind of show that, hey, these tools are great and all, but there are still risks associated with them. Auto run is not just set it and forget it. You do still have to be wary of certain pitfalls. Thankfully, the Cursor team was amazing. They were able to get these fixes in super quickly. But yeah, no, they're just some interesting risks that just have to be made, that you just have to be made aware of. Further on top of that, we had a little bit more fun once we figured out those auto run bypasses. We found out that you could actually have Cursor chain its own vulnerabilities and kind of spread malware on its own. And that's where our Cursor virus came in. We had a bit of fun with that one. We had a little prompt that essentially pretended that it was a license file, and that would allow Cursor to essentially spread this prompt to any repository that was touched within that context window, so the window that the language model was actually seeing. And that allowed us to spread our prompt basically everywhere.
Yeah, and what was really interesting about all of those attacks, so I know Ken said it's been about a year since we actually did those initial attacks, and a lot of those attacks are still here today. But one of the things that we've noticed in some of the red teaming we've done, some of the vuln research we've done, is that you actually don't need to use a lot of those attacks to actually perform attacks nowadays. And that's just with how all of these agents are designed. So at the start of today's webinar, I talked about, a prompt injection is when you actually have to bypass a guardrail. You have to get around the model rather than just being able to tell the model to follow something. However, the way that all these harnesses are being built and the way that we're interacting with the model itself makes it so that you don't actually have to really have a prompt injection. You're able to get the model to just follow certain instructions without anything actually going poorly at all. There's quite a few different spots that do this, most noticeably skills nowadays, which I'll let Kieran talk about in a few minutes as well. But some of these architectural designs that are causing these issues are things like control sequences. Models are trained with something called control tokens. There has to be some way so that the model knows what is the system prompt, what's the user prompt, what's a tool output, what's a tool input. And the models have learned pretty much that there's these tokens that the model should use and that are in the chat template. And most of the time now when you see, a system prompt leak or any system leak, what you'll see is that you'll see these XML-like tags that look very much like control tokens, but they're not actually tokens themselves. Because what you have to keep in mind is that tokens are pretty much the vocabulary that the model knows. So each one token is pretty much one single ID that gets sent to the model. So these, they might look like control tokens, but they're actually sequences, multiple tokens together. The original cursor attack that we did used one of these control sequences, where what they did is they wrapped every single user prompt in user info or user query, which meant that as an attacker, what you could do, since in the system prompt, it defined that anything that had that XML-like tag user query was automatically a user instruction. And the model was trained not to follow tool instructions, but it was trained to follow user instructions, was rather than a true prompt injection, what you could do is in a tool output, you could simply wrap something in a user query tag, and the model would treat it as a user query, just because it would just follow. You didn't have to have some advanced prompt injection at that point. Yeah, go ahead.
No, sorry, I was going to say, that I was literally going to jump in and say, if anyone wants to see, we've got a blog on that, and the previous webinar we did as well, it's about 4 months ago now, like March time, I think. I don't know how we're in nearly at the end of July already. But around 4 months ago, Ken and Connor and Ken did a breakdown of all of that as well. If you want to go back and see those, the user query tags that were key into getting those attacks to work. I'm struggling with words today. It's fun. Was there anything else you wanted to add on to that, Kaz?
Yeah, I wanted to go into the tool side before we go into skills, because I think it sets it up really nicely. And Kieran definitely did a lot of our original MCP style attacks. So Kieran, do you want to go into that a little bit?
Yeah, so one of the main things that we found, or one of the first things we did with the MCP style attacks was finding how much the model or the agent actually uses the instructions within an MCP and where you can bury them. So you can inject instructions into description fields, you can inject, but you can also one of the things we found was you could inject instructions into the tool function parameters. And so you could hide instructions in there by injecting an additional parameter in there and have it do additional things other than just what the original prompt was asking for when it initially called the tool. So yeah, that was probably one of the things that triggered and started it off.
Yeah, and that just goes into that concept of the way that we're building these harnesses is directly opposed to how we're training the models in terms of security. So what Kieran was describing with those attacks is these models have been trained to be instruction following. They're meant to follow, any instructions, any tool definitions, any tool parameters. So what that means is that when we're building these systems, if you put something malicious inside of a tool definition, inside of a tool parameter, you can get the model to do anything that you want it to do without a proper prompt injection. Another big issue with these is that the tool definitions are often getting injected directly into the system prompt itself. And I think that leads us to the issue with skills, the latest research that we recently published.
Yeah. Is it worth, do you reckon, dipping in on kind of OpenClaw and the influence of skills kind of coming from that side, or do we just dive straight in?
Yeah, I think that's great. I know Ken and I did a good bit of research into OpenClaw. Ken, you want to give a little quick summary of what we had there?
Everything's on fire and we're all going to die. But no, in all seriousness, I mean, it was an interesting project because it showed kind of how people really wanted to use these agents, right? They wanted a little box that you could kind of give to an LLM and just have it do everything in your life, which in theory sounds awesome. But in practice, there were a lot of different risks that came associated with that, right? You had basically a bunch of different system prompts that were all different. You had things being called constantly, and you had who had the ability to actually edit files on a system, right? So when you combine that, it might sound like a really big jumble, but you had an agent that could write things, right? So you could have a prompt injection, write into a file. You had files that were kind of running every so often, kind of like a heartbeat. And you could essentially have any function or any tool or any malicious command inserted into that heartbeat and just have it sort of trigger, which was not great. And I know Kaz has his thoughts on this and he can go way deeper into it. But yeah, no, it was this huge mess of, hey, this is cool and all, but security was a total afterthought when this was built.
Yeah, and OpenClaw and just a lot of the artifacts that came from OpenClaw has left security and just harnesses in general with some interesting little leftover bits. So the first is there's that whole concept of these dynamic system prompts, which are very useful. However, there's not a lot of security around them. So as Ken was mentioning, you could write files, but then the system prompts were actually files on the device and could be edited by any interaction that was done. However, I think the biggest change was with the tools and the skills. So first off, skills actually really became a thing, which leads to all the issues that we have now. But with the tools, we shifted from going from purpose-built tools for every single interaction. For example, I might have had a tool that would let me grep files for a certain string. That could be an actual built-in tool. However, with OpenClaw, we saw the shift, not just with OpenClaw, but across the board, for good and bad reasons, where now everything relies on bash terminal commands. So rather than a tool being built to search files for a string, it might use grep, or it might use a different type of find command that is on the terminal. This allows the agents and the harnesses to be a lot more dynamic. The models can do a lot more with a lot less limitations, with a lot less things being needed to be built. You don't have to build a custom tool for every single interaction you want. But at the same time, it makes it a lot harder to actually audit anything. With models, going back to our threat report, Jim, because I know you've done a lot with that as well. We publish a yearly threat report for those who don't know. We can flash the link later here to download it. But there we talk about all of the issues that are seen, as well as a few predictions that we make. And one of the key stats that we had this year, and I forget the exact number, so I hope you forgive me, Jim, was that a lot of the companies out there and enterprises, they wouldn't know if they would actually know if a attack occurred because there's just no observability. And that was before all of the skills and all of the bash terminal commands was really a thing. So now we're at a point where we already had a lack of observability, a lack of being able to see what the agent can do, what tools are being called, what the harness is interacting with. And then now you're making it so that we have bash commands that could be in any order, do anything that we want, rather than a predefined order where we can extract out an exact string.
Yeah, that makes a lot of sense. Like, I think it comes back, the desire tracks back to what Ken was saying earlier with like the auto run mode in Cursor, right? Everyone wants a box, everyone wants Jarvis. Like I could do with Jarvis because first off, I forgot to remind people to submit questions. So if you've got any questions, submit them. I could do with a Jarvis to tell me that at the start of this thing. But that whole idea of an auto run mode of like, just do things that are helpful. And to do things that are helpful, you have to grant more autonomy to it. But it also means that you can't be over reliant on these specific tools. So you then have to open up how tools are going to be called. And if you can just put like a bash one-liner into a skill file and rely on exec to run it, then it makes it so much easier to get a Jarvis up and running to do your bidding, right? Like it's this idea that the promise of AI being able to solve an awful lot of problems without an awful lot of human intervention is kind of where we want to get to, but we want to get there securely. But like, where's the balance? And it feels like we're flowing from one side to the other quite often, and we're probably more on the let's get things to do things right now.
Yeah, and I actually think that's a perfect transition over to Kieran's research. Since, one of the big issues, as you mentioned, is just the models being able to run any commands that you want. However, at least now we have permissions. So, if somebody doesn't want auto run mode on, they can say, yes, I want this command. They can actually review it. I don't know how many people actually do that, but the option is there. However, a lot of the research that Kieran did for skills in the frontmatter, and I won't steal all your thunder, Kieran, but it made it so that you no longer had the option to actually review what commands were being run.
Cool, yeah, thank you. Yeah, so actually this kind of started back when Ken was talking about when OpenClaw first became a thing. Jim will remember this well. He and I started like digging into trying to understand what sort of stuff was going on to like OpenClaw's hub and different skills hubs, and see how people were actually like using skills and sharing their skills, and then looking for stuff that was like suspicious or malicious. And what was interesting at the time when it first started was that we were seeing a lot of similar like attacks where it's like, you know, in the body of the skill, there's like Kasimir was saying, like one-liners that are basically pulling down and executing malicious scripts and stuff like that. And they were just kind of getting posted and reposted and then posted with different users and things like that. So we started to dig into like, okay, well, what else can we do with skills other than just that? How dangerous can these be, you know, more than just that? And so looking into like the skills and how they're put together, they start with like a YAML section, which is referred to as frontmatter. And then underneath that, they have the body, which is kind of like the section which it describes what it's doing, describes commands and things like that. In the frontmatter, there are different frontmatter fields that are kind of documented for different harnesses, different agents. And so we were looking through the one for Anthropic, for Claude Code, which it is very well documented. They have a lot of functionality and a lot of features in there. And one of the ones that stood out kind of immediately was that they have a frontmatter field called allowed tools. And what we found that enabled us to do was like add different tools that kind of bundled in with Claude Code, and the skill would then be able to run that tool. So the commands and prompts from the skill would be run within the context of that skill within the context of the allowed tools. So if you have something in the skill that calls bash and you have an allowed tool that is bash, then that command will get called without ever actually asking the user's permission, because the allowed tool is already set in the frontmatter field. So something malicious could be hidden, or not so well hidden, but in the body that calls a tool that, you know, you might not necessarily want it to call as the user, but it just calls it without permission. Same for things like webfetch, stuff like that. So yeah, that can kind of be used. That was the sort of first thing we looked into. Just on that as well, like other coding agents have that field too. GitHub actually for Copilot has a warning on their website about like, make sure you absolutely trust this before you set allowed tools. Make sure you look at the allowed tools field, stuff like that. Mistral Vibe also has it as well. So it's not just Claude Code. So to kind of build on that, because obviously it could be potentially quite obvious if you've got the body of a skill that has like a malicious command in it and you've got bash as an allowed tool to run, we looked at where else we could maybe hide the prompt, the malicious prompt within the skill, as we kind of talked about earlier. And so you can do that within the description field. So skills must have a name and description field. And so you can you can put the prompt into the description field. However, when you call the skill as a user, the name and the description comes up. And if you look on any skills hub, the name and description and the body are all there, like visible to the user. So, you know, if you're reasonably careful, you'd be able to see it and stuff like that. But there are also as I mentioned, there's so many other frontmatter fields. You can actually hide prompts in there. So one of the ones that we used was a field called when to use. And the idea of that is that you can have the skill be called by a trigger action, essentially. So you set that when to use, you know, if a user asks about a website, do this. And so that kind of, you can hide a prompt in there, like a malicious prompt in there. And if you then, when the user calls the skill, like with the / menu or something like that within their coding agent, they see the name and the description, which looks fine. And they see the body of the skill, it looks fine, but you can't see the when to use field. It's not actually displayed. And on multiple skills hubs, you have to like drill in to actually see the full content of the frontmatter. So you can see that like that additional prompt in the when to use field. So what we were able to do was hide or put allowed tools in, like bash, webfetch, things like that, into the allowed tools. And then in the when to use field, we would say, you know, once you've completed this, use webfetch or use bash to read .env and webfetch to, you know, send this to a webhook or whatever. And it would do it. So there's kind of having to have that understanding that there's these items within the frontmatter that are also part of the skill infrastructure that you kind of have to be aware of. And kind of to take that even a step further, we were finding that obviously, sometimes the model or the agent will refuse to do such a thing, and raise the alarm, and it would say like, I found this, and I recommend you delete it from the skill and don't use the skill. So what you can actually do is set the model and effort level within the skill front matter as well. So you can it's like a downgrade attack. So you kind of lower the skill level of the agent. So the skill is then called in that context, and the model is less likely to refuse if it's kind of downgraded, which was quite interesting as well. Then we actually flipped it on its head and created a perfectly legitimate skill, but set it to run at like maximum effort with like the highest model level. And obviously then it's burning through tokens and costing you a lot more money. So it's kind of like a denial of wallet style attack as well. So yeah, we kind of, and all these things, like the key thing about this, like I said before, is that, if you go onto a skills hub or, whatever, like you can see the name, description, and body. That's typically what's there. And obviously a lot of people are aware, like look in the body for anything that might be suspicious, or, if there's something in the description that's suspicious, you can kind of see it. But you would have to drill in a bit further to see like if there's these kind of extra items in the front matter fields that can cause damage.
That was amazing. Like very detailed. If anyone does have questions, I didn't kind of push out hard enough before. If you do have questions on everything that Kieran's just gone through, I've got a couple, but like please do submit them. We'll try. We are planning on saving like 10 minutes towards the end for questions. So yeah, please do get them in. So the front matter like seems like crazy important in terms of how the skill is going to run, or how the harness is going to interpret it. Is that kind of
Yeah, so it sort of sets the context for the skill to run. So you can even, there's even a field that is user-invocable. So normally in like Claude Code, let's say, again, not that I'm picking on you guys, you would invoke a skill with a slash command. So, slash call the skill, or, write the skill name or whatever to call it. And that's how you would invoke it manually. But you can also, as I said, I mentioned with the when to use front matter field, obviously that's a trigger that's being set, but you can also add there's a field that's user invocable that can be set to false. So you can create a skill, potential supply chain attack or whatever, like, put it into a project where a skill can get invoked in a certain way. And there's sort of a level of persistence there then where you make it user invocable false. And what that actually does as well is it tells the harness, Claude Code, this skill is not user invocable. So when you start typing in the slash menu, you can't see it. So that skill is actually hidden from user view. They can't see it. They don't know what it's doing, and it will trigger the whim of the attacker, whatever they decide to put there. So in the attacks that we did, in the kind of blog that we wrote about, we talked about some of these the things that I've already talked about, but yeah, there was ability to execute commands that shouldn't have been allowed, exfiltrate data, things like that, doing the downgrading and the denial of wallet attacks and things like that. But we were also able to poison memory. And the reason for that was that the read tool doesn't ask permission to write to memory files. So you can actually use a skill, hide a prompt to write to a memory file, and then the harness actually has that memory stored in the project then for the user. And so what we were able to do is create a memory file that persistently adds malicious code to an HTML file. So it's like whenever you create an HTML file, add this malicious code to it. And then if the skill is deleted or whatever, you still have that level of persistence that's then built into the memory of the agent too. So yeah, to answer your question, those front matter fields kind of provide the context for the skill execution.
Yeah, and Jim, just to add a little bit of extra context here, because Kieran was saying so much awesome technical stuff that he actually, I think, lost over one crazy part of skills in the front matter. So Jim, you're on a threat intel team. You've had to go through how many skills at this point?
Over tens of thousands,
right?
If not hundreds of. Yeah, there's a lot. There's a lot out there.
Are they normally on the shorter side, the longer side? What do you think?
They can be pretty verbose.
Okay, so
yeah,
exactly. So most of these skills are really long, and sadly, tokens are not cheap. I wish they were. They're still cheapish, but you don't want to waste tokens on everything. And a lot of people have a lot of different skills inside of their system at this point. So you end up with this problem of you want a lot of different things loaded in your system, and then these things that you want loaded in your system are all really long and have a lot of information on them. So what happens is, rather than loading the entire skill every single time you're doing anything, the front matter is what's actually loaded into your system prompt, and it's loaded directly into your system prompt. So that means that anything within the dash, that front matter section, which is pretty much a YAML file, gets just automatically injected in. So as we were talking about earlier with tools and some of the issues that we've seen with coding agents and their harnesses up until this point anyways, is that you don't really need a prompt injection at this point anymore if you're inside the system prompt, because if you're inside the system prompt, you can tell the model to do whatever you want. So what Kieran's attack with the front matter lets you do is anything that's in the front matter, so the name, description, the when to use field, all of those other fields, they will be treated as the system prompt, and they're automatically loaded in every single time because they're what the model uses to key off what full skill files it needs to load in.
That is kind of frightening. But yeah, so it's like you add your prompts to that section, to that YAML file. You've got ways in which you can hide it. You've got ways in which you can sorry, you said maximum effort before, Kieran, and I'm like, oh, that's got to be the Deadpool attack now, right? Like, it can't be denial of wallet. It is just Deadpool.
I spent like so much energy trying not to mention Deadpool when I said that. So.
Just rely on me to say what's in front of everyone's mind. Okay, but yeah, so you've got the way in which you can downgrade the model that it's going to use. If you downgrade the model that it's going to use, then those, obviously the size of the model is smaller, so its understanding of what it should alert you to, or say this is potentially dangerous, reduces. So you've got a higher chance of it running without being alerted to it. You can hide it in fields which stop you from seeing it in the first place. Like, it's a dangerous place. It feels like, yeah, everyone gets access. Whoever writes a skill is going to fill out that YAML section. Or is the YAML section, is that front matter optional?
The front matter, you have to have the name description. The other fields are optional. However, because they're optional, all the ways that we browse and interact with skills, they don't actually show it. And that's one of the things Kieran was trying to say with Claw Hub. So, you on our threat intel team, you download the raw skill file. We actually analyze all of that. However, if you actually use Claw Hub and you look at the display that they do, they pretty much render the skill.md as markdown, and they try to do some prettying up of the front matter. But unless you actually go and look at the raw skill.md file, you're not going to the front matter. And most of the scanners that are on there don't look at the front matter either. So you run into this issue where the way that we're actually trying to verify whether or not the skill is correct or safe and benign does not actually show you the bad parts. So when to use, for example, the model specifically told that it should use that field to specifically follow instructions, but when to use is only there for the model. So that's not going to show up on Claw Hub. That's not when the skill asks for permission to run, it's going to give you the name and the description. So even if you audit all the scripts that are there, any binaries that are there, the actual skill.md file itself, the description, even if you're looking inside of Claude Code, you're not going to see that malicious component. And then that skill does not even have to use the bash command or shell script that was provided with the skill. It can run something completely different.
Amazing. This is sounds like you guys have had a lot of fun doing this. There's nods. All right, awesome. So that's a lot of the ways in which we can start to use skills from like an adversarial perspective to get an agent to do something on a system, right? What options do we have from the other side of things? Are there any ways in which we can start to like try and think about the security side of this, and how could we potentially look at this in a different way?
I can.
Yeah, go for it. You're doing all our research into hooks, so
that was where I was trying to get to, was hooks, and I didn't want to say them up front.
have been someone with like an incident response and digital forensics background, this is kind of where something that really interests me is the hooks. So each coding agent or harness has different what they call hooks, and they can be applied at project level or a global level, but they still will run together. And basically what that does is it tracks what the agent is doing. So when a user submits a prompt, it can, you can log like the prompt, you can log what caused the session to start, you can log a tool being called, when a tool, so the tool call, the tool response, and you can map those together, you can map everything that the agent does, and things like that. So, from that perspective, different harnesses have different capabilities, let's say, when it comes to hooks. So I know we kind of just talked a lot about Anthropic and Claude Code. So to kind of balance that out, like theirs is really good. The hooks that they provide are very like comprehensive, and they cover a lot of different things. Too much to kind of go into detail here, but like all the stuff you really want to see, you can see with Claude Code with the hooks there. So yeah, as I said, you can see if the user submits a prompt. So what and even things like it's called like user prompt expansion. So if the user calls a skill, you can see it with that hook. So if the user manually invokes a skill with a slash menu, that's logged via the hooks, and you can kind of send the hooks to wherever you want to keep observability of that. I would say like familiarize yourselves with the different hooks if you're wanting to kind of track and observe what's going on at that level. So it's kind of like, rather than necessarily like, obviously there's kind of scanning skills and looking for suspicious things in the files on the systems themselves, but there's also kind of tracking it as it's running, and observability and logging. And yeah, hooks are kind of the key way to do that and see what the agent's doing, what the user's doing, what the different tools are doing, arguments, parameters, things like that. So and one thing I just want to add on hooks as well, though, is something to be mindful of, is that they can be abused, because obviously they're running every time an action happens within the session. The one that we've seen being abused in the wild is session start. So the session start hook, every time a session starts, it can run a malicious command. For example, if that would be an attacker approach. So they can be abused. So that's also something to watch out for and keep an eye on. But yeah, using hooks is a really good way of like debugging and keeping that observability of what that agent is doing in general, and that also will lead into kind of keep in check on what's happening with the skills.
And so the hooks, I'm pretty sure you mentioned it, but they're different between the different coding agents, right? Like,
correct.
It's not a standard set of hooks. So what's the coverage like for, like, do you get complete observability, or is it like partial, or like, are there any gaps worth knowing about?
Yeah. So, well, yeah, I don't want to like say anything bad, obviously, but like I was saying, really, like Anthropics are like really comprehensive, really good. There's little things here and there. It's the same with Cursor, like not as comprehensive, but still you kind of see the main things that you need to see. As Kasimir mentioned earlier, Cursor, or maybe Ken, Cursor are really responsive. So, I've had a few things where I'm like, oh, I want to be able to see this, but I can't. And I feel like I should be able to see this. And so you submit a ticket and they're like, yeah, we'll look at that literally like the same day. So yeah, an example would be if a file is being read by the agent, that should be a tool call that gets sent to via the hook. So then the person looking at the logs can see, like, the Cursor tried to read this file. What was happening was, if the file was open in the IDE, in the editor, it wasn't actually triggering. So little things like that. So it's just like being mindful of little things like that, I would say. But yeah, I would say Anthropic definitely the most comprehensive.
Yeah, and I mean, say it's definitely not a silver bullet if you're trying to build your own security solution, specifically because of little issues like Kieran just mentioned of, the file read would work if the file isn't open, but if it's open in the editor, it will open that way. There's also other little subtle issues. For example, some new things that get added, new features, you might expect that it would be going through the normal pre-tool use or post-tool use, but like file read, file update are their own hooks. So what you can sometimes have is that new hooks can be created, and that might steal functionality from something that you are expecting. And that's why so much research has to go into keeping them maintained, seeing all the little quirks. So it's a lot more than just using a hook to fully secure yourself.
Yeah, that makes sense. The whole space moves so quickly, right? And the power of hooks is becoming apparent, but we're not in the end state yet, or anywhere near what the end state is. So,
it's insane. Like just the amount the hooks have changed since I started looking at it probably a couple of months ago. Is crazy. How much it's changed. So yeah, still a long way to go. And yeah, totally echo everything Kasimir said there.
Amazing. I don't know if Kaz, if you had any other questions, or if we move on to if we have any recommendations from an architectural perspective.
Yeah, so I would say, the hooks are great. They're not a silver bullet. So of course, we always recommend making sure that you go through and you have some sort of third-party security solution. A big reason for that is because actually Ken is on this call, so that's perfect. But Ken and another researcher named Connor, over a year ago now, pretty much proved that these models really can't protect themselves, and you have to have, a tool can't guard itself for the most part, especially since these things are built to follow instructions. So we have to be mindful of, we need something outside of the LLM itself to guard the LLM. And then we need some way to actually go through and try to protect these systems. It's a little bit different than original chatbots, where with chatbots, you just had to be sitting between the user and the model. Now you have to sit between the user and the model, any external data in the model. So it could be any tools, which, as we saw, tool data can come in many different ways. It's not just one hook for the tool. It's a hook for the tool, another hook for a file read or a file write. Sometimes the data can come in outside of a hook, even though it's data that we'd expect to come in from the hook. So whenever we're trying to go through and defend an agent or try to secure it a little bit more, you have to be very mindful of where different pieces of context come from, and then their level of trust and the scrutiny that we have to give those. For example, a user saying delete a file is completely fine, but that cursor example, if it's coming from a tool, that's not fine. And then what we always recommend as well is going through. In our OpenClaw blog, we actually published a lot of the architectural security weaknesses that we commonly see that we talked about today a little bit. So, going through and making sure that you have auditability on the actual tools rather than, just full terminal that can do anything. Being mindful of those control sequences you use. Can you rip them out? Can you make sure they're not abused by something else? And then definitely making sure that you have a strong system prompt and doing a lot of system prompt hardening. Because if you do not explicitly tell somebody or tell the agent what it can't do, then somebody asking it to do something it can't do doesn't really matter, because the agent was never told that it can't do something, so it'll still go through and do it. Ken, is there anything that you wanted to add for the architectural side?
I think you got it pretty much all covered.
Amazing. Should we transfer on to some questions? Sounds like a plan. All right, let's have a look. We have one from Timothy Y or Timothy. Sorry, I don't know why that came into my head. Anyway, what security controls should be prioritized between an agent and its tools, given the possible exploits using frontmatter, parameter injections, etc., described by Kieran?
Yeah, I can start off with that, and then Kieran, I'll let you go through and give some extra pieces there as well. So it's a great question. I think I might have answered some parts of it just now. So I do want to break this question into two parts. So I know you're specifically talking about the front matter components here, but we do also mention the parameter injections. But I think the most important security control that should be prioritized for any agent you're building is doing a threat surface and looking at the threat surface for indirect prompt injections. So indirect prompt injections are going to be very different than prompt injections in the first place. And a lot of the traditional vulnerabilities that we've seen, just ever really, because the payloads are completely different. In the past, you had to have a payload that had to be sent a very specific way, had to hit an endpoint a very specific way. However, now with prompt injections and specifically indirect prompt injections, you can just do watering hole attacks. So that means that as long as any text or even any image makes its way to the model in some way, shape, or form, you can take over that model and you can do something bad. So that means you have to monitor, are you accessing websites? Are you accessing arbitrary code repositories? And those are the ones that people are starting to get a bit more used to. But we've also seen some very fun ones. Ken's done some of these where you have indirect prompts coming through very, very weird things that you wouldn't necessarily expect. So, back with traditional security, we talked about if something's behind a firewall, everyone always, said it was safe. Not very true, but, we would always joke about that. And a lot of that mindset is still here for agents too. So what we've seen is, a chatbot, an internal chatbot that's hooked up to like an HR database, and it goes over customer reviews or customer feedback. You might think that because that's all central, it's coming from customers, you're not accessing arbitrary things on the internet, that might be safe. However, are those customer reviews coming through people that you can actually track, which is not necessarily great either? Or is there just a random form on your website? And it's trying to think through that attack surface is definitely, I think, the thing that has to be prioritized most. As for what we were talking about today, so for the parameter injections that we were talking about, and Kieran was talking about with MCP specifically, that actually has a very interesting supply chain risk. And it's because the MCP, just the schema, the architecture of MCP is made in a way that you can't really verify or hash servers. So not so much of a risk for the standard IO, the local MCP servers, but for remote MCP servers, those could be arbitrarily changed at any point. So that means if I have a remote MCP server that I'm accessing, don't want to throw any real company under the bus, so we'll say Catfax. I have, Catfax MCP, where every single day I get a little bit of information about Catfax. It's, something fun. Could be the same. It could be something else. Could be my weather one, or, anything out there that I might access daily. A lot of people use it. A lot of people trust it. What can happen, though, is that either it could be a threat actor, a malicious actor, or they could be supply chained in one way. And then the way that MCP works is every few seconds, it pulls the server to see what tool parameters are there. So when the remote MCP server is modified, rather than my Catfax or my local weather, since I'm traveling right now, getting pulled in, it could, either still have that same function name, or it could be a completely different function name. Like I could have a tool saying verify SSH keys, and then the parameter says upload SSH key, something like that. And because that is already getting added to my model system prompt, my agent is going to trust it. I never know that there's a difference because I can't really see the tools. And a lot of times, because I might want that every single time I don't have to press allow permission for, get the weather, because that's something I consistently use over and over. They could keep that same tool name and add an extra parameter for, SSH key or whatever. Those parameters, if those change, that doesn't invalidate the allow that I give that tool. So that's a big issue with, the tool side of things. And then finally, the front matter, that one, it's more so about auditing it. So there are ways to scan skills, which I don't think we have time for in today's talk. But I promise you, we have a lot more content coming out about that, as well as 2 blogs. But you can look for some of those fields. Look for if it has that model field, if it has the effort field. Is it trying to raise it all of a sudden so that it's using extra high Fable to review something rather than the defaults on it? Or is it trying to go to haiku because it's trying to dumb down the response? Is that extra field of when to use there? That's something that you can easily check, because most of the time those won't be paragraphs on paragraphs. And if it is multiple paragraphs, chances are it's going to be malicious. So it's more so being able to spot check those right now until more automated solutions come out, and make sure that there's nothing bad there. Kieran, do you want to add anything for the front matter, since I know that was all of your research there?
No, man, I think you covered it perfectly, really. Yeah, I would have said the same thing, really. So yeah.
This is why you guys work so well together. You know what each other's thinking. Cool. Right, we got another one. It's from Timothy again. I'm really sorry, dude. If I ever meet you, I apologize in advance. What are the biggest gaps you guys see in the current AI red teaming methodologies reporting? And what attack classes against agentic systems do you think will become most concerning in the coming years? Oh, it's a prediction one. Who wants to do some predictions?
So I say let's give this one to Ken, but I actually want to throw you in for a little loop here. So we are talking about methodologies, reporting, and attack classes. And weren't you the creator of some taxonomy lately?
I'm not. I cannot claim to be the creator. I was the cat wrangler to make sure it happened. I was not the creator. But yet, when we start thinking about like taxonomies from the prompt injection side, and we're working on something internally to look at the skill side of things as well, and how those might overlap. That's way far off being anything public. But the taxonomies, you can start to use them and break them down. The attack classes with skills are really weird in that you are looking at attacks against both the agent and the system and trying to get the agent to attack the system, or is it direct against the system? So you have like multifold different taxonomies to take into account when you're in that space, which is an interesting space to be in, to try and work out what those are going to be. But it draws on a lot of things that we've already done, and trying to think about a lot of the attacks and a lot of the ways in which we've seen stuff in the skills that we've reviewed have been similar to attacks that you would have seen before. But instead of writing a piece of code to do it, you're writing a prompt to do it. You're writing a skill to go and do those actions on the system instead of getting access to that system some other way. So you can kind of fall back on what it is that we're seeing. Did have another point, totally lost it. Should we throw it over to Ken? And I might think of something again in a second.
All right, fine. I mean, it's interesting because I've kind of seen the field evolve from basic disregard all of the above and move on, and it's been kind of interesting to see how techniques have expanded. So you have all these different kinds of prompt injection techniques, jailbreaks, all these different kinds of instructions that can totally override what a language model is doing, and that kind of peaked and actually started shrinking down to what actually matters. Right, so you've got your techniques that are very simple. You've got your gaslighting, which for some reason still works today. I mean, not for some reason, we kind of understand why. But the idea behind that is essentially like the attack surface of a model is kind of is exploding, right? You've got agents that have access to just about everything. And I mean, there's two schools of red teaming in AI. You've got your AI red teamers looking into security, and your security red teamers looking into AI. And I mean, each one of them kind of covers a different set, right? Your security people are looking for different kinds of attack surface problems or things that kind of go into agents and are looking incorrectly, but they might not have the full comprehension of all the techniques that they can use to actually get to that point. On the AI red teaming side, it's the exact opposite, right? You've got a load of techniques, a load of different tactics, but you're not sure exactly of where that scope is. And so I think the biggest gap really comes in when you look at both of these, right? You can explore a certain technique, right? With traditional red teaming, there's usually a door in. But with AI red teaming, what's fun is there may be 100 or 1,000 techniques that you can use, some of them not discovered yet, that will allow you to manipulate a model into creating the door rather than just having it exist and using it as an exploit.
That's very eloquent, dude. I wish I could explain stuff like you do. Cool. Right, we got like a couple of minutes, so we'll start to finish everything off. First off, we've got some extra resources. This is where I really test Ryan and see if he can keep up. Oh, look at that, he did as well. He's so good at this. So yeah, if you want to read about any of the blogs or anything that we've talked about today, so Kieran's blog around all of that frontmatter stuff. We have blogs on. There was a couple more around skills. I forgot what they were now. We did have a chat before this, but I've been so focused on remembering to mention that me and Kaz are going on a holiday to Black Hat in a week's time. So if you are at Black Hat, come and say hello to us. There are some blogs that you can go and do some extra reading on. I highly recommend going and reading through the one that Kieran wrote about the frontmatter stuff, because of like the layer on layer on layer of how things get worse is just it's one of those where you go, oh, how bad can it get? Oh, it continues to get bad. So yeah, it's an awful lot of fun. Yeah, I think if you are a Black Hat, hit me or Kaz up on LinkedIn, or hit HiddenLayer up on LinkedIn, and we can meet you guys. That'd be cool. But yeah, I think all that's left to do is say goodbye from everyone, really. Kaz, Ken, Kieran, thank you so much for explaining some stuff to me. I'm sorry I kind of mumbled my way through the most of it, but you guys were awesome, which is what counts. So yeah, everyone have a great rest of your day. I'm going to go make some pizza. So have a good one.
Thanks, everybody.